Hi everyone and welcome back to Matthew Wizard. Today we're going to be talking about half reactions in chemistry. So to start off, half reactions is basically just the individual reactions of either reduction or oxidation. So oxidation, as a recap, it involves the loss of electrons. So if we look back at our acronym oil rig, we can see oxidation involves the loss of electrons and reduction involves the gaining of electrons. Now, whether we're losing or gaining electrons, we're going to see that in either the products or the reactant side. So when we're oxidizing, right, whenever we're losing electrons, we're going to see that in the product side. It's like what's being released. But if we're gaining electrons, we're going to see that in our reactant side. So if you look here we have a full redox reaction where we can see oxidation and reduction take place. But we're going to look at the half reactions. We're going to look at the transfer of electrons more specifically. So to start off, we have Ag. Now, in our reactant side, we have Ag+, and we can have our invisible one there, and it's turning into simply Ag. And since Ag has no specific charge, we can consider it neutral, so it's at 0. So what we're saying is that we're going from a +1 to a 0. So let's just pretend we have a little number line right here. We have 0, -1, 1, 2, -2, right? So this is where we start. We start at a +1. We're positive. But then we end up becoming a 0. We end up moving more towards the negative side. So what's happening is that we're gaining electrons. And if we're gaining electrons, that means that we're going through reduction. Gaining electrons, which is reduction. Now, if we're gaining electrons, if we look back, we're going to put that in our reactants. We're going to show that transfer in our reactant side. So what we're doing is that we're adding electrons to the more positive side, which we see right here in our rule. We must have both sides of the half reaction equal each other. So that means we need to add electrons to the more positive side. So now, if we think about it algebraically, right? How can we get a +1 to turn into a 0? Well, we would actually have to subtract 1, which is the same thing as adding a -1, which is adding an electron. So the half reaction, the electron transfer that we're going to see here, is that it's going to look like Ag plus and E minus turns into Ag. Now what we're seeing here is that in our reactant side, we're adding an electron. And that electron is going to cancel out with the positivity, with the cation that we see in the reactants. And it's going to balance the half reaction. Now if we look at Cu in the reactant side starts off as just Cu. It has no specific charge, so we're going to make it 0. And then after the reaction, it becomes Cu2+. So what we're seeing here is that it's going from a 0 to a 2+. That means it's becoming more positive. And if it's becoming more positive, we're losing negativity. We're losing electrons. So we are losing electrons, which is going through oxidation. Because now, rather than gaining electrons, what we're seeing here is that we're going from a 0 and then we're becoming a +2. So now we're actually going more towards the positive side. So now we're going to rewrite it where we're going to add electrons to the more positive side, which is in the product side. Because in the product side, we have a 2+. Or actually, let me just fix that. That's a +2. So we're going to write it as Cu, right? Transfer to Cu +2 plus 2 electrons. Now the reason why we're adding 2 electrons specifically is because it's going to cancel out the +2. So think of it as +2 plus a -2, it's going to equal 0. Just like we had it here in this situation, where we went from a +1, we added a -1, and it turned into 0. So this is what's basically happening in half reactions, where we want both sides of the half reactions to equal each other. However, before balancing these reactions, we do need to make sure that the number of atoms are equal on both sides, which is what we did here. So again, as I said earlier, we had 1 Ag, 1 Ag, 1 Cu, and 1 Cu. And that's how we were able to do both these things.